Hello everyone, and welcome back to a new video in programming the finite element method using MATLAB. I'm very happy to announce that this would be the last video about the entire calculation, and it's going to be the last video where we are really like coding for our lives, because we are basically approaching the end of the controller life cycle here. The last function that the controller needs to do is to calculate the actions. And then we can basically continue our work on the viewer, modify a little bit, make it look better. But basically that's it. I need, of course, to perform some debugging and some benchmarking, but at least the controller and the finite element method code would be, in that case, full circle. Because the last thing after finding the internal forces is to find the reactions, and this would end the analysis of the finite element method. Now, of course, we're going to improve the viewer. I'm pretty sure there's a ton of bugs here that I still need to kill, but I think we are approaching the end of this video series. So with that being said, we're going to dive into the calculate actions. But before I start, I want to give, of course, my reminders to you that this is part of a finite element method playlist talking about the theory and programming, and that there is a playlist alone about programming, which is also linked on the top right. Also, my dear channel members have access to the entire source code. However, if you're not a channel member, then don't worry, because every single line of code will be written in front of you, and you can write along, and you'll have the exact same code as mine. So that being said, and without further ado, sit back, relax, and enjoy the show. Okay, calculating the actions could be viewed as being straightforward. There is not much shenanigans to do here. What I will do is I am going to loop through all the nodes. So here there is a for loop from 1 to the length of the object.stir nodes. I'm going to loop through each of them. Now you need to remember that the reactions are not inside the nodes and not even inside the fembars. We need to pick out the reactions from the fembar springs. Now, how do we get that? Well, first of all, I need to find the fembar responsible for the support. So what I will be doing here is I'm going to declare a support fem node. That's what I need to find. And also a support fembar. Those two dudes are two things I need to find. I need to find the fem node, and which would lead me to the fembar. So let's find the fem node. So here, which means that I would need a for loop. I would go for a for fem node indexer. The ER has a reason, because I would have a variable later that is called fem node index. So I added an ER to kind of discern between the two of them. Here I'm going to go through the object.fem nodes. And of course, here I'm going to switch through every single one of those fem nodes. So first of all, if the fem node does have a corresponding stir node. So if is object. Wait, I need to pick it out. Give me a sec. Fem node equals object dot fem nodes at the fem node indexer. So I picked it out, and now I need to make sure it has a corresponding stir node. So is object fem node dot corresponding stir node. If that's an object, then it exists. And now I can ask another question. I can ask if the fem node dot corresponding stir node dot id equals my target node dot id. Now my target node, I think I should fish it out. Did I fish it out? No. Let's fish it out. Node equals object.stir nodes at the node index. So I'm fishing out the node. I cannot simply ask this question like this, because there is a chance that this dude doesn't exist. And if this dude doesn't exist, I would get an error. So first of all, I check if it exists. And if it does, I check if the corresponding stir node.id is the same as my node ID. If that's the case, then this fem node is assigned to this stir node. But that's not enough, because if I have a support, then there are two fem nodes that share the corresponding stir node. That's not enough, because only one of them is correct. And to fish out exactly which one of them is the correct one, I need to check if it is indeed a support node. You see how all those properties come into play right now. If that's the case, then I can say that indeed support fem node equals the fem node. I found it, and I can save it now. So now we save it here. I will comment them out now. So now here I'm fishing out the support fem node, which is basically the fem node. Fantastic. Now we have the fem node. Since I have the fem node, I must break out the loop to kind of conserve resources. And now we have the fem node. Now using this fem node, using the support fem node, I'm going to say here, using the support fem node, find the support fem bar spring. So since I have the support fem node, now it's time to find the support fem bar spring. And how we do that? Well, we loop another loop. I will go for fem bar index from 1 all the way to the length of object dot, I think it's called fem bar springs or something. Not really sure. I think that's the case. Okay, so let's fish it out now. Fem bar equals the object dot fem bar springs at the fem bar index. I fish it out, and now check if the fem bar has our support fem node. If it does have it, then this is my support spring. How do I do that? Well, I basically ask the question, if the fem bar dot fem node 1 dot small letter dot id equals the support fem node dot id. So if it is the same id, then the fem bar has our fem node, and also the fem node is the first node. So in this case, I need to highlight that this fem node that I'm trying to find, this fem node that has a support, is fem node number 1 in the support, because it could be number 2, by the way, we don't know. So here I'm going to give something else here. I'm going to basically call in a fem node index. I will make it equals -1. What I mean by fem node index here is I want to know if the fem node is the first in the support or the last in the support. So what will happen here is it's the first. I'm going to here say fem node index. This equals 1. It's the first. And also support fem bar is going to equal fem bar. And then I break out of the loop because I found whatever I'm looking for. Now that's one question. I think he doesn't like it, so let's remove that. Also, there is another chance that the same thing, fem bar dot fem node 2 this time, dot id equals support. That this fem bar is indeed my support. However, the support fem node is fem node number 2 in that bar. In that case, fem node index is going to equal 2 because I need to know exactly where my support is, and that the support fem bar is going to equal fem bar, and I will break out. Otherwise, I can continue looking until I find it. So now, by the end of this, what do we know? We know now which fem node the support is, and 2, we also know which fem bar the support is, and we also know which node in the fem bar my fem node is. So that's what we know so far. Now we're going to use this knowledge to kind of get the global reactions and pass it into the node. So here I'll basically cycle through all the load cases. So I'll go for a for loop here, for load case in index equals from 1 to the length of object.str load cases, and end it here. And we're going to pass through it. Now, first of all, I need, like, I don't know, it's kind of annoying. Let's make dof equals 6 here. I should make this constant or something. Now here, let's get the global forces first of all. Let me say, first of all, support local forces, okay? Now in this case, this equals the support fem bar dot local force matrix. I have the support local forces. Now, I need to go for the global forces. Fun fact, the global forces and the local forces are equal because the supports are in the x direction, because I did not implement any rotation of the supports. So this step now is going to be useless because I'm going to call in support fem bar dot transformation matrix transpose multiplied by the support. You know what? I can just dash it in one sentence instead of declaring a variable. You know, just everything in one sentence. And this is useless because this is going to equal this, because that transformation matrix is the identity matrix. So now I have the global forces. Still, I need to abide by the rules. Here, the Fx reaction is going to equal the global forces of. Now here's the thing. The global forces have the x forces at node 1 and the x forces at node 2. Which node should I select? This is where the fem node index comes into play, because it tells you exactly which node you should use for fishing out the fx here. So what ends up happening here is I'm gonna call in the fem, just making a bracket here, fem node index -1 multiplied by degrees of freedom +1. And of course here the load case index. What this means is, if it happened to be the first fem node, then the degrees of freedom are going to be 1, 2, 3, 4, 5, 6. If it happens to be the second node, then this becomes 6 plus 1, 7. So 7, 8, 9, 10, 11, 12. I hope this made sense to you. Now here I have the fx. Let me just copy this entire thing, because I must paste it 5 times. And since I have the reactions, I can gloriously go to node.reactions. I'm just realizing that I forgot so far to make the polar moment of inertia for rectangular sections. Okay, fine, whatever. Load case index and 1, this is going to equal fx. Node.reactions, I can just copy and paste this 6 times or 5 times. We are done the hardcore coding stuff here. We still need to do our benchmarking and need to do our code checks and whatever. But for now, I think the cycle is complete and I can breathe a sigh of relief. Okay, fine. So what remains is, I think there was something about the polar moment of inertia, and maybe I'm gonna program in the controller how to delete stuff, like deleting a node maybe not, I'm not really sure. I need to think about it. And of course, we're going to have some fun with our viewer, which we kept somehow not touched. But I think that's a video for another time to worry about. So yeah, that is indeed everything I wanted to talk about today. I am very proud and very happy, and I hope that you enjoyed the video. In the end, I want to give a almost completed sized shout out to my dear channel members in the contributor level and the helper level, whose names are going to be shown on the screen. I want to thank them from the bottom of my heart, as their support of the channel is priceless to me and enables me to provide you with videos hopefully on time and with a certain quality I try to achieve, and for that I am forever thankful. In the end, I hope that you enjoyed the video and you found it beneficial. If you have enjoyed the video, then please consider liking, sharing, subscribing, commenting, and so on. Especially subscribing, because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel. I will catch you in the next video. Bye bye.